This video is about solving polynomial equations using factoring. We'll also talk about the zero product property. Let's get started. First, let me give you a definition of zeros, or also called roots, of a function. Okay? They're the same thing. We use them interchangeably. So a zero, or root, of a function that maps from the real numbers to the real numbers is a number of x in the domain such that f of x equals 0. Okay, so it's the number for x that if I plug it into the function, then I get it's equal to 0. Okay, so that's really what a root or a 0 is the value of x at which I can plug in to the function and it will equal x. Okay, so this really kind of drives how we solve equations. We will typically want to get one side equal to 0. Okay, so here is one example of that. We'll solve number 4 here. Okay, I want to get one side equal to 0. Okay, that's kind of the first step in solving these equations, which, by the way, is different. Like in questions like number 1 here, this is a linear equation. Okay, and you were taught, and drilled into the fact in Algebra 1, if you have a linear equation, you get all your numbers on one side and the variable on the other, and then you divide, and that's how you solve it. And that's very true. That is the best way to solve a linear equation. But once you move to quadratics or cubics or fourth degree or anything other than linear, then it's useful for us to get one side equal to 0. Okay, now this already is solved for 0, which is nice. Okay, and so the way I get one side equal to 0, and then if it's factorable, we're going to factor as far as we can. Okay, again, as I mentioned earlier, that factoring often makes complicated problems into much more manageable pieces, even though factoring as a process is cumbersome, but you can get good at it and it make a lot of problems simpler. So I'm now going to try to factor this trinomial. Okay, by this point, by the way, if you're just coming into this video, if you're uncomfortable with factoring in different ways, I have a series of videos about factoring, so be aware of that. Okay, now this is a trinomial where the leading coefficient is 1. Okay, so this is our simple ABC method, or the simple version where I have two binomials. Okay, and I'm looking for two numbers that will multiply to be 6 and add to be 5. So I'm looking for numbers that multiply to be positive 6 and add to be positive 5. They're both positive, so I have positive numbers. Let's see, I have 1 and 6 and 2 and 3. The pair that adds to 5 is my 2 and 3. So I have x plus 2 and x plus 3. All right, so I'm just factoring. Okay, now we'll look at this one right here. This trinomial, it's a trinomial. The leading coefficient is 1. It's a simple ABC method. So I have two binomials where x and x. Okay, I'm looking for two numbers that multiply to be -4. So one's negative and one's positive. And the bigger one will be negative because it's -3. Okay, so let's hear -4 and +1, and -2 and +2 won't give me a positive. So -4 plus 1 is the pair I want to get +3. So I get -4 and I get +1, and then don't forget that you still have an equals 0. I know if you've been focusing on factoring and factoring and factoring, you may forget about that equal sign, but you don't lose your equal sign. Okay, and when you're solving an equation, keep your equal sign. All right, so the next idea, before we can do this next and last step, is the idea of what's called the zero product property. The zero product property is the idea that 0 times anything is 0. Okay, and that's super useful for us right now. So for example, if this term right here happened to be 0, okay, like if this term happened to be 0, it wouldn't matter what these are, because 0 times anything is 0. Similarly, if this was 0, it wouldn't matter what the other 3 were because 0 times anything is 0, and all the way down, right? If I can look at when each of these factors are equal to 0, then I would know, what the solutions are, okay? And so I ask myself, for this term, what number plus 2 is equal to 0? When is that equal to 0? Well, it's true when x is equal to -2, right? When x is -2, that's 0. The other factors are other things, but 0 times anything is 0. That's the zero product property. Okay. This term right here, what number plus 3 is 0? Well, it's going to be, let's see here, -3 plus 3 is 0. So x is -3. All right. This one, let's see here, what number minus 4 is 0? Well, 4 minus 4 is 0, so x equals 4. Okay. And then what number plus 1 is 0? Well, it's -1 plus 1 is 0, so x equals -1. Okay, if you're noticing the pattern of hey as the opposite sign of the number, that is true when you have x plus or minus some number. If it's more complicated, like 2x plus 3, then maybe put that equal to 0 when you solve. Okay, so that is how you solve polynomials. The first step is that you get one side equal to 0. If it's factorable, which we hope it is, it's easier if it's factorable. Okay, we then factor it. We set each of the factors equal to 0, and we solve. Okay, that is the process we go through. Now, just to kind of fill in some of the missing pieces here, this over here, number 1, that I did very quickly, is a first-degree polynomial because it's the biggest exponent is 1, and there was one solution. Okay, this, if I multiplied it out, would be x squared times x squared, which is x to the 4th, so it's a 4th degree polynomial equation, and I have 4 solutions. And we'll talk more about the fact that, the number of solutions is the same as the degree, okay, and how that plays into it as we move on. But I want to talk about it at least right here. Now, I want to look at one more equation together. The last one I want to do is number 8 here, okay, where it's not already factored or halfway factored like the last one we did together, okay. So again, that first step is to get one side equal to 0 because this is not linear, this is quadratic, it's a second degree polynomial equation. So our first step is to factor, and hopefully we can. Okay, this is a trinomial. It's a trinomial with the leading coefficient to be not equal to 1. So this is the more complicated ABC method. Okay, and I'm going to multiply A times C, which is 2 times -2, which is -4. Okay, and I'm looking for numbers that multiply to be -4, so I have a negative and a positive, and they add together to be -3. So it's the bigger one's negative, so I have -4 and +1 and -2 and 2, but that's not bigger. So this pair does add up to be -3. Okay, so I split up this one. This is just factoring with a factoring trinomials with a not equal to 1. If you want to review that video, you can. But 2m squared, I'm going to split up my -3m into two terms according to this, -4m and plus 1m minus 2 is equal to 0. So splitting that term up. Okay, and then from here I do factor by grouping. This is normal, factoring, but don't lose your equal 0. So these two terms, the biggest GCF is 2m, and I have m minus 2. Okay, this has no GCF, so I'll do plus 1 because I get the same m minus 2 that I want. And these two, m minus 2, should be the same in both of them. And then I factor out this common factor out of both of these terms, and I get m minus 2, and I get 2m plus 1 equals 0 left. Okay, so just all the way from an equation, I factor it, and then I have factors equal to 0, and then I use the zero product property to set each of the factors equal to 0. Okay, so what number minus 2 is 0? Well, 2 minus 2 is 0, so m equals 2 must be one of my solutions to this equation. Okay, 2m plus 1, what number times 2 plus 1 is 0? And this is one where you can't just like change the sign of the second number because there's a 2m. So just to make that super clear, I'll write down 2m plus 1 equals 0. Now this one is linear, so I'll get my numbers on one side, my variables on the other, and divide. So I will minus 1 from both sides, and I get 2m equals negative 1, divide by 2, and m is equal to negative 1/2. Okay, those are the two values where this equation is true. Okay, this video was about solving polynomial equations using factoring. Thank you for watching.